Hi, guys. Let's go ahead and jump right in. We're going to get to 10.5. So apply other angle relationships in circles. We're just about the end of chapter 10, so we're going to be having a quiz probably next week. So email me with any questions and keep working hard like you are. Let's go ahead and get to it. Okay. So this is going to okay, this is theorem 10.11, and what it's saying, if a tangent, so a tangent hits a circle once, that's this line here that I'm highlighting on the bottom, and a chord is a line that hits two ends of the circle, if they intersect at a point on the circle, point A, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, what I want to emphasize is that this is actually not a new theorem at all. This is the same idea of just an intercepted arc and the angle. So what I'm doing here is extending the arcs, or excuse me, I'm extending the rays of the angle. So angle 1 is actually intercepting this red arc. So angle 1 is going to be half the red arc. Angle 2 is going to be half the blue arc. This is the exact same idea as intercepted angles and arcs, okay? So I don't think it needs a new theorem, but the book likes to give it to you. So let's go ahead and make it simple. And I'm going to do the first one. You should pause and then you do the second one, okay? So in A, line M is tangent. That's important. So you see a tangent and a chord. It can't just be any old line. Remember, it has to be a tangent. So if this arc here is 130, that means angle 1 would be half of that. So angle 1 would have to be half of 130, which would be 65 degrees. Okay, so you simply just take 130 and divide by 2. So for B, they're giving me the inscribed angle. I'm actually going to type that word because that's what it is. It's an inscribed angle. Okay, and that's from the previous sections. So 125 is the inscribed angle, which means this red heart here would be 250 degrees. You know, we could even get crazier, and I could actually find arc KL. So there's two ways to do it. One, you know, a line is always 180. So 180 minus 125, that would make this 55 degrees. So if this angle in here is 55 degrees, 55 doubled is 110 degrees. Now think about it this way. A whole circle is 360 degrees. 250 plus 110 is 360. So effectively, I just checked my work. So why don't you guys go ahead and find the major arc, AB. Find the major one this direction. So pause it and please find it. Okay, welcome back. So I asked you to find the major arc, arc AB. So we know this minor inscribed angle is 65 degrees. So then we know the rest is 180 minus 65. That would be 115. Okay. So then this 115 would be double to make it 230. So this big arc here would be 230 degrees. Again, you could check it. 230 plus 130 is 360. All right, let's get to our next example. So pause it here and try these three, and then push play when you're ready. All right, guys, so welcome back. Long time no see. So they want a measure of angle 1. Well, if the major arc here is 210, and I'm calling it major because it's clearly bigger than 180, then angle 1 would be half of that, so angle 1 would be 105. So I could get crazy and go to the other side, but there's no need to. You didn't ask me to. All right, number 2, find the measure of arc RST. Okay, so they want this arc this direction. So that would be 98 times 2, which is 98 times 2. I'm grabbing my calculator. I despise mental math. I don't want to miss it. That would give me 196. All right. So that major arc is 196. Now, number 3, they want the measure of arc XY. So I know it's the small direction because it's only got 2 letters. They would give me 3 letters if they wanted the big arc, the major arc. So if this here angle is 180, then that means the intercepted arc would be twice as big. So that would be 160. You know, just to reiterate, so my answer here is 160. But to reiterate, you could check the other side. If this angle here, by the way, it's talking about this whole angle all the way to the line. If this angle is 80, then this angle would be 100 because it's supplementary. And then this would be 200, your arc. And then 200 plus 160 is 360. So keep these simple, keep them logical. You've seen these before. Okay, so here we've got examples of where two lines can intersect on a circle. We have worked with this case here. This is the only case we've worked with. I'll highlight it, I'll circle it. And this would be where you have the intercepted arc and the inscribed angle. Let me type that here. So this is the inscribed angle and intercepted arc, okay? Now the next two cases are what we're going to talk about next. This second case is what I call the butterfly. And that's because what's happening is if they intersect on the inside of the circle, you create basically butterfly wings. Here, I'll draw the cute little butterfly so you can see him. It's a butterfly with crooked wings. There we go. There's your little butterfly. Putting decorations on the wings. There's your little butterfly with crooked wings. So I call that the butterfly. And then if it's outside the circle, I'm going to call it a solar system. Okay, that just helps me remember like the situation. Like think you got a little planet on the outside, and then you actually have two intercepted arcs. You have a small intercepted arc, and then you have a big intercepted arc. So these two cases we're going to talk about next. Get ready. Okay, so first let's talk about the butterfly when the lines intersect inside the circle. Okay, so to find the angle that is within the butterfly wings, it's averaging the two arcs. So let me actually I'm going to give you a real example here. So let's say this arc here is 60 degrees, okay? Let's say this red arc on this side is 100 degrees. So to find angle 1 would equal the average of, so that would be 60 plus 100 and dividing by 2, because you would average them. So angle 1 would equal 160 divided by 2, which would equal 80 degrees. So that means this angle here is 80 degrees. It's simply just taking the average. Now to find angle 2, you know angle 2 is supplementary to 80. So if this is 80, then angle 2 has to be 100 because 2 and 1 are supplementary. Now this 100 has no relationship to the red arc here being 100. It just happens to be the numbers that I picked. Okay, so I'm going to clear this, and we're going to do this first example down here. I got caught off because it has the solution there, but that's not quite a solution. Don't worry about that. We just want to find the value of x. I didn't post the solution because we're going to work it out. Okay, so x is going to be the average of your two arcs. Okay, so angle x equals 130 plus 156, and you're going to divide by 2. So that would equal 130 plus 156 is 286, and we're going to divide by 2. And that would be 143. So measurement of angle x is 143. That's it. You simply take the average. All right. We're going to skip this. I don't think these scenarios are any good. It doesn't help. It just can kind of make you confusing, but these are all different scenarios. If you care for it, it's the solar. So we're moving on to our third third topic where it's the solar system idea, where you're going to have a planet on the outside and then it's going to have two intercepted arcs. Okay. You're going to have a big intercepted arc and a small intercepted arc. So planet, big intercepted, small intersected. Planet, big arc, little arc. These all have the same theorem attached to it, so I don't want to stress too much on that. What I want to show you are examples and the theorem behind it. Okay, so let me go ahead and give you numerical values for the first example. So let's go ahead and say that this red arc here is 100 degrees. And then let's say this blue arc here is 40 degrees. They want the measurement of angle 1. Okay, so this theorem down here is, it's very close to the butterfly. The butterfly theorem is where you add the two arcs and divide by 2. Now, when you've got the solar system, the planet on the outside, you're going to subtract the two arcs. So I like to think of it as angle equals big arc minus little arc, and you divide by 2. So I'm not saying it's the average, because average is when you're adding, but you're going to be subtracting. Okay, so to find angle 1 in this first example, it would be angle 1 equals, so your big arc is 100, and you subtract 40, and then you divide by 2. So that's 60 divided by 2, so that would give me 30 degrees. So this angle in here, this angle 1 is 30 degrees. And that's referring to this angle coming in here, kind of like the flashlight shining on the planet. So angle 2 is the same, or sorry, to find angle 2 and angle 3, they're the exact same. It's always going to be big arc minus little arc. So I'm actually going to give you numerical values and have you try to find them, and then push play when you're ready. So let's go ahead and say this first value. Okay, so, well, let me give you a little tip on this one first. Let's say this red arc is 260, okay? Oftentimes when they give you this scenario, they only have to give you one number, and they could say, go. And the reason being is because the whole circle is actually accounted for, unlike in this example where you've got some circle not being intercepted. But here, the whole circle is being intercepted. So if this red arc is 260, the blue arc has to be remaining. And remember, a circle's 360, so that means the blue piece would have to be 100, because then it would equal 360 total. Okay, and then let's see, let's make up some numbers here. I'm gonna make this one ugly. Let's say the big arc 75, and let's say the little arc is 12. And you find angle 3. Okay, so please find angle 2 and angle 3 and push play when you're ready. All right, welcome back. So angle 2 is going to be big arc, so 260 minus little arc divided by 2. So that would be 160 divided by 2. So that would be 80. So angle 2 is 80 degrees. A little bit. I'll draw an arrow to it. Okay. Now angle 3, same setup. So the angle is equal to big arc, which is 75 minus little arc, and divided by 2. So you should never get a negative angle, because that's impossible. So it's always going to be big minus little, okay? So 75 minus 12 is 63, and then you're going to divide that by 2. And you're going to get a decimal, which is completely fine. You can have decimal angles. So angle 3 is 31.5 degrees. Okay. All right, so I'm going to clear this, and we're going to scroll down and have you do this example here right below it. All right, find the value of x here. All right, welcome back. So what you see here is it's the solar system example, so it's going to be big arc minus little arc divided by 2. So angle x is equal to 178 minus 76, and you divide that by 2. So that will then turn into 102 divided by 2, and then that equals 51 degrees. Angle x is 51 degrees. So guys, please don't make these harder than please don't make these harder than they should be, okay? There's always a ticket out, so use your problem-solving abilities as well. Let's go ahead and clear this and move right along. This is actually our last slide. So number 6 is very hard. Number 4 and 5, fine, we can do those. 6, boom, it utilizes every skill you've learned this whole semester. Okay, so I want you to pause it and try them. See how far you can get on 6. When you get stuck, push play and follow along. I'm sure your jaw's going to drop and be like, seriously, Miss Cunningham? And don't hate me. It's just good. I'll give you a hint. You have to use some trig. And yeah, okay, I'll see you in a minute. All right, guys, welcome back. So let's see. You've got a lot of theorems you're working with. Number 4 is the butterfly. Okay, because see how your 2 lines are intersecting on the inside. All right, so what's going on here actually, this 102 degrees is related to these butterfly wings here that I'm highlighting in green, arc BC and arc AD. So 102 is actually not what I'm going to be using to find Y, but I need 102 to find the angle that it's supplementary to. So 180 minus 102 would make this 78. Okay, because remember, this is your butterfly wing. 78 is related to the 2 wings Y and 95. So let's go ahead and set this up. So angle Y, no, sorry, the angle 78 degrees is equal to the average 95 plus Y divided by 2. So the angle is equal to the average of the wings, okay? So this is going to require some algebra. So the first thing I would do, you know, I actually don't like dividing by 2 written like that. I'm going to handwrite it like this. It's better to write it like that. So let's go ahead and solve for Y. So the first thing I would do is put this over 1, and then I would cross multiply. Okay, so 78 times 2 is 156 equals 95 plus Y. And then 156 minus 95, so Y is 61. There we have it. Okay, number 5 would be a solar system example. Okay, because look, you've got the angle on the outside of the planet, so it's like its own planet shining on this, okay? So to set up 5, you're gonna say the angle 30, is equal to big arc minus little arc. So your big arc is A, because it's further away from this angle, so it'd be A minus 44, and then all divided by 2. All right, so it's very similar to the butterfly, it's just a minus instead of a plus. Okay, at this point, then I would cross multiply. So 60, I'm gonna type it, it's easier and quicker. So 60 equals A minus 44. So then I'm gonna add 44 to both sides. So that would be 104 equals A. Okay, and what I was just doing mentally was making sure, so if this is 104, I was just doing some self-check, like this better be bigger than this intercepted arc here, because this is your bigger arc. And then 104 minus 44 is 60. 60 divided by 2 is 30. So good, I like my answers. All right, I'm gonna clear it. I need a lot of room to do number 6. So in fact, I need so much room. I'm going to cover up 4 and 5. I need them out of my way. I need space. All right, so let me draw 2 shapes to cover everything up. Let me fill it with white. Oh, I think I have to redraw it. Okay, here we go. All right, we got a lot going on here. We're looking for this giant arc X, okay? So actually what I wanna do first is redraw it just so you can see what I'm seeing here. So I'm going to redraw it without this line in the middle just for a second so you can, I'm making a plan, okay? So we got, oops, I'm going to undo that. I'm going to use an actual line, okay? Okay. All right, so we're looking for X, which is on the outside, the giant arc, okay? Really, guys, if we could find, and I'm just going to assign them different variables, if I could find this little arc here, arc Y, and if I could find this angle here, Z, I would be good to go. Because really what I'm going to say is angle Z is equal to big arc X minus little arc Y, all divided by 2. Okay? So if I could find Y and Z, if I could find this is Y, and if I could find Z, this would be Z, I'm good to go. So now I need to utilize the picture on the right. Okay, so what I got going on, remember how I always say radius is so important. This is a radius, this is 3 here. This is also 3, this is also a radius. This is also a radius, this is also 3. Why is that important? Because now I have a right triangle, which I'm going to just draw below it. I'm drawing TQS here, best I can. And this whole length would be 5. 2 plus 3 is 5. This here is 3. I'm going to label my vertices. This is T. This is S. And then this is Q over here. That's not a Q. Okay. Now, so you've got TQS. And yes, I'm being annoyed that that was a lowercase t. My perfectionism is coming out since it's being recorded. All right, so I've got TQS. Let's go ahead and make this a right angle as well. Okay, so guys, I drew this upper triangle here just to kind of hone in on it. So what I see is this is a right triangle, so I could do Pythagorean theorem or recognize it's a 3, 4, 5 triplet. So I can see that this is 4. I don't necessarily need to know that this is 4. What I really would like to get is this inner angle here. That would be really nice. So I'm going to go ahead and call this inner angle, let's call it A, okay? If I could find A, that would give me this angle here, and then I could double it to get the whole angle. All right. So how would I find A? I would use trig. Now, because I have all 3 sides of the triangle, I could use sine, cosine, tangent. It doesn't matter. So I'm going to go ahead and use, you know, guys know I love sine. So A is equal to, so angle A is equal to, sine of angle A is opposite over hypotenuse. So that would be 3 divided by 5. I'm going to write divided by properly. Sine of angle A is 3 divided by 5. Now remember, to get the actual angle, that's when you have to use inverse. So we're actually going to do sine inverse. So sine inverse of 3/5 should give me angle A. Okay, so obviously I'm going to use my calculator on that. There's no way I could do that in my head. So sine inverse of 3 divided by 5, I'm getting 36, and I'm going to round to the nearest tenth. So I'm getting 36.9 degrees. So A is 36.9. All right. So what that means is 30, so this here is 36.9. Now, if I doubled 36.9, that would give me 73.8. So this whole angle here, guys, is 73.8. What I just found was angle Z, 73.8. Yay, that's huge. I got one of my angles. I got Z, 73.8. Okay. Now I can find Y, because what I have here is this is a central angle. A central angle shines on its inscribed arc and would be the exact same. So what I'm actually going to do is find the angle right here. Now I know a triangle adds up to 180, so I'm going to do 180 minus 90. 180 minus 90 minus 36.9, and I get 53.1. So equals 53.1. So 53.1 is to the other angle of this right triangle. Okay, so that's to angle S. Okay, so 53.1 doubled is 106.2. So what I just got is this angle here. This is 106.2. Because that's a central angle, that's going to be the exact same measurement of this arc here. So that would be 106.2 as well. So we just got Y. Whoop, whoop. Okay, guys, so we got 2 out of 3 variables. We're ready to do the math. Let's go ahead and fill in what we know. So I know Z, which is 73.8. That's equal to X, big arc, minus little arc, 106.2, all divided by 2. Ooh, that was a horrible line. I'm going to redo that. Okay. So obviously now I'm going to cross multiply. So 73.8 times 2 is 147.6. 147.6 is equal to X minus 106.2. So now I'm going to add 106.2. And I got 253.8 is equal to X. Okay, all right. 253.8 is equal to X. So that is our answer. I obviously know that's intense, but here's also a way to check it. And I really, really like this. You know, a full circle is 360. Okay, so you know this should add up to 360. So to check it, it would be 106.2 plus 253.8. Does that equal 360? I think that's like spot on, which is making me really excited. Ooh, that's exactly 360. Makes me excited because we did some rounding here with our trig, but it still came out so perfect. If you were close, if you got like 361 or 359, that's good, guys. We'd use, anytime you use trig, know that you're going to be rounding. But this came out perfect and makes me happy. So that is it for today. I hope you guys had a lovely lesson. I hope you enjoy your homework. And as always, email me with any questions. I'm always here for you guys. All right, I'll talk to you soon.